Hey guys, I am Varshit. Today I am going to be your host of explaining about a sorting technique and related to sorting we are going to discuss a problem. So let us get started. So basically basically, let us take a quick recap of what we are going to explain today. So, yeah, the first we are going to dive deep into the sorting. I mean, definition of sorting, what is meant by sorting, and stuff related to that. Yeah. Now, types of sorting. See, there are many types of sorting techniques. One might come with one approach, and other might come with other approach. See, sorting is basically like an ocean. You can explore it any way you possible, but the best way is going to be decided by two factors, time complexity and space complexity, that I'm going to be explaining in short while. So, before going to these all, so sorting is dependent totally upon what your time complexity will be and stuff related to that. Talking about beginner coders. So talking about beginner coders. So yeah, um, let me give a quick recap about introduction to sorting. See, sorting is basically let us say you have a bunch of apples, okay, a rotten one, a small size, a big size. So it will be too you know it will be too difficult for you that you have to pick one apple and you have to store it in a basket and throw the rotten ones away and place the smaller apples under the basket and make the bigger apples on the top. So let us think those apples as a data. So as we say, as we say that if we talk about an ascending order, let us say if I'm going to arrange the data in an ascending order or in a descending order, what I'm going to do? Obviously, I'm going to use arrays, right? So in Python, we are going to use less. That's a different topic. So in the whole explanation, I'm going to express the arrays as list. Okay, so yeah, what there is no big difference between arrays and lists. They are both the same, but the difference comes when let us say I have an array of size 14. So the 14 size is very fixed with the array. Let us say yeah, let us say the 14th element, or it will be difficult for me to add an element, or I need to I'm not satisfied with 14th size, I need a 15th element, or I need an nth element. So it will be very difficult for an array. Of course, he obviously uh, offers you malloc and calloc, but it will be too, you know, too difficult for the computer also to handle and append all this. So let's up the concepts I'm going to explain, which can be used for let us say I have my array, you know, I have my data, but I need to increase or decrease the size of it. So I'm gonna use less. So having that in introduction, I'm going to deep dive into the concept. See, sorting is basically it is an algorithm used to rearrange a given array or list or elements according to a comparison operator on the elements. See, this is on the paper, but let me give you a quick and simple definition. So, sorting is basically let us say I'm going to shopkeeper and I'm asking which are the I need only the sweet oranges I need. Yeah, I need only sweet oranges, and he will. I'm going to pick it up from him. See, basically, it will be too. too difficult for me. If the sweet orange is placed at the last and I am searching it from a pile of rotten oranges, right? So the same way, it is very easy to search an element which is sorted, right? So sorting, it's the advantage of sorting that you can basically easily search an element. That is one kind of it, right? So if you see Amazon, yeah, if you see Amazon, the I can tell you which order we need to sort it, high to low price or relevancy. Those all comes under sorting techniques, right? So basically, the general definition of sorting is a sorting algorithm is used to rearrange a given array or list of elements according to a comparison operator on elements. The comparison operator is used to decide the new order of elements in respective data structure, right? Uh, yeah, this is the brief definition. You can read it. You can pause the video and take a, rec- take a quick recap. So yeah, that's all. So see, sorting techniques. I'm not going deep, but I will be in short. But sorting technique. Sorting is see, an ocean can be explored from anywhere, right? But we have these techniques to overcome. Uh, I have a list of 14 elements and I need to sort it in ascending to descending. All will have a different approach, right? But the approach with less time complexity will be considered, right? So it is not possible that I am going to take a long route from uh, India to America. That's wrong either, but I can take a shortest route and in shortest time. See, that's possible. Okay, so many sorting techniques are there. Many intellectuals came with different sorting techniques. Okay, among them are bubble sort, insertion sort, etc. Okay, see, you can see the uses of data structures. I mean, um, See, sorting holds a crucial role in data structure due to its fundamental impact on data organization and retrieval efficiency. Here are some key points highlighting the importance of sorting in data structures. Efficient searching. Sorting enables quicker and more efficient searching of data. When data is ordered, searching in data structures provides algorithm like binary search that can be employed dramatically reduce search time compared to unsorted data. In variance application, okay, imported reveal imported retrieval. Invariance applications, including databases and information retrieval systems, sorted data can be retrieved faster. This is crucial for systems handling larger data sets that require rapid access to specific information. Algorithm performance. Many algorithms perform optimally on sorted data. Sorting enhances the efficiency of algorithm like merge sort and quick sort in faster processing time. Identifying patterns. Sorted data makes patterns and trends more apparent, aiding in data analysis. Simplifies tasks like identifying outliers, understanding distributors, and drawing meaningful size. So, actually, data apart from apart from these uses, I can give my own, like, we can say, in it, you all search various websites. Let us say, I'm typing what is the body for HTML in HTML. So there will be lots of websites coming for me, but Google suggests me and sorts the relevant, I mean, rele- relevant web addresses to me. Yeah, that will comes under sorting only. See, uh, there is a site called W3 Schools that will be first displayed, and it is also secured and assured by McAfee, right? See, and second comes Geeks for Geeks. Third comes like some other website, right? Uh, See, these and the website with less security, less approved by McAfee will come last. See, these all comes under sorting, right? Yeah, that is the main key application of the like sorting. The sorting can be used in anywhere. That's the use of sorting, and main users are displayed in PPT as a show. See, these are the sorting techniques widely used, but there are so many sorting techniques. See, I can compare this with you see, I can compare this with how many programming languages we have. There are in like I think 500 plus or 400 plus. I don't know the exact figure. So I can say that you see, I can say sorting techniques are many, but uh, I'll give a quick recap. When you type in Python, you say sorted, right? For sorting a list, you say sorted, right? But if I say sorted, it will come from descending to ascending, right? So higher to lower. So in sorted, uh, according to Python, it uses quick sort and merge sort. Combination of these two to get to the closest and faster approach I need. That's what the Python intention, right? See, okay, okay. Among these sorting techniques, we have heap sort. See, I'm gonna I'm gonna explain this heap sort because it is very important, by the way, and also heap sort is used in many applications. Apart from that, I'm not telling that a merge sort is also important, but it is very reliably important when you come for any game development software. I'm gonna like you see, I'm gonna explain this with a real life game. Yeah, for that you need to stay tuned. Yeah. See, heaps sort. I'm going with the general definition. Heap sort first convert the array into heap data structure using heapify. Then, one by one, delete the root node of max heap and replace it with the last node in the heap, and then heapify the root of the heap. Repeat this process until the size of the array is greater than 1. Okay, this is the this is in short how heap sort works. See, basically heap sort is nothing but you can imagine like yeah as a tree. See, on the top of the tree you can imagine a maximum or minimum value, and okay, we can imagine like this. How can we say? Yeah, ununiform bogie train, right? At the top, always at the top, the engine train will be there, and it is followed by nonetheless, let us say some passenger trains, or let us say coal exporting trains, or let us say vegetable trains. It might be irrespective. I don't need any of the you know any of the elements beside, but I need only the engine train. Yeah, that is the closest approach you can get. See, build a heap from the given input array. Swap the elements of heap with the last element of a heap. Remove the last element. So yeah, that's the same. Okay. Yeah, I'm going with the algorithm of heap sort. Okay, see, I hope it's visible. See, let us say an array of yeah. Let us say it's an array of 4, 10, 3, 6, 1, right? Yeah, 4, 10, 3, 6, 1, right? Yeah. It's a rough, let us say, yeah. Now it is visible. Yeah. It is a rough. He had given us a rough picturization of a heap. See, this is the normal structure as we are going. Let's imagine this. Okay. This is the initial structure. I'm not going with a heapify, but it's, let us say this is the initial structure. And see what happens if I heapify it. See, here the author goes like, yeah, I'm going with the maximum value. Okay, this heap value will be the maximum. Okay, for that, what the author does is, see, he first takes and he first takes. See, remember one thing. If the author is saying, yeah, I'm pointing out. See, this is the this is the root node, right? Yeah. Well, I'm going to discuss it later. What is root node? Okay. Till until then, just say this is root node, right? See, this root node is connected with 10 as well as 3. But when I use max heap function, what happens is this 10 will be swapped with 4. Yeah, you can see that. It is going to be swapping with 4. Okay, now this is the second step of this. But what does heapify stage? See, what happens if I say, I'm going to take a quick recap. See, let us assume two oranges, right? Yeah, two oranges. I mean, oh yeah, three oranges. Let us take three oranges. One is smaller one, and two are bigger size one. See, if two are smaller size and one is bigger size, I'll take these oranges and I'll keep in a pyramid form. Okay, let us say I'm keeping this small orange and I'm keeping this big orange. If I keep, can I able to keep that big orange at the top? No, right? Like, you can see, no, you can't keep a small orange on the bigger one. You need the same size as one to balance it, right? But if I remove that and swap with the bigger orange, now two small oranges can obviously balance the bigger one, right? Yeah. So you can imagine that, okay? Yeah. You can see this was swapped with 10, okay? Yeah. Now this 4, let us now I'm using the same logic. Now this 4 was swapped with 5. Okay. Yeah. Now this will be the final heap tree. Okay. Yeah. Now this is the heapification process. But what I need, the max element must be removed according to heap sort, right? So for that, see, whenever you're going to implement with Python, I'm going to show with you, uh, I'm going to show you with the code and problem solving. Just remember to import heapq function, right? That's the inbuilt function. Actually, it's a huge code to write again and again. So Python actually offers us uh, built-in function. Okay. Yeah. Yeah, you can see that. Now when I perform heap heap pop, remember this heap pop function shall eliminate the first element present at the heap queue. Okay, now the 10 will be get eliminated and 1 comes. See how this 1 comes. I'm going to tell you. See, at the root node I'm displaying the smallest one. Yeah, you can see 10 has its smallest child as 1, so it will come here. But what max heap function says, I need the largest value at the top, right? So it will be unbalanced and heapification will be going on and resulting in this. I hope you understand that. Yeah, same with this. When you pop the element, the heapification process will be get on. And at the end of the day, I'm gonna end up with this kind of array, which is basically sorted one, right? this is I mean, this is the sorted, I mean, heap sort method. Or let us say, I can actually perform this by, see, if I'm gonna pop it and I'm gonna stack, I mean, yeah, it will be better. I'm gonna pop it and I'm gonna stack it, that like stack data structure. I'm gonna store it in and I'm getting the sending order at the end of the day. So this is what the author has done. So time complexity. So before going to actually discuss the time complexity of heap sort, I'm just gonna give you a quick recap. What is time complexity? See, the time complexity of an algorithm quantifies the amount of time taken by an algorithm to run as function of length of input node. Note that the time to run is a function of length of the input and not the actual execution time of the machine or algorithm is running on. The valid algorithm takes a finite amount of time for execution. The time required by algorithm to solve a given problem is called time complexity of algorithm. Time complexity is very useful for measuring algorithm analysis. I hope you understand it. If you didn't understand, just pause the video and read that definition. Okay, or else if you are not satisfied with this PPT, you can actually google search uh, google search it in W3 schools and you will get it. Okay, now the problem statement. See, this is the problem statement. I'm going to give you 5 seconds to read it. uh, yeah, I'm just pause the video and thoroughly read it, and you can comment it down what have you understand. So yeah, see, basically, if you come this far, uh, if you figure it out, just comment me. Okay, see, basically Jessie has some cookies in her, like, see, what is she telling? See, sweet, yeah, every time, see, every time she mixes with cookies, we can see the equation, right? 1 into least sweet cookie plus 2 into least sweet. See, let us say I have a set of cookies. One is less sweeter. If I add another one, it will be like 1x times sweeter. If I add like, it will be 1x sweeter. See, if the let us forget about sweetness. Let us say I have some cashews in cookies. Okay, if I have some cashews in cookies, if I add the second cookie, the cashews will be double, right? So yeah, that is the, like, in the second cookie there are more cashews than first cookie. If I add it, then the cashews will be more, right? So this is what the problem statement is, and you can actually look this problem statement in HackerRank also. Yeah, yeah, you have to sign it up. Yeah, yeah, and big shout out for HackerRank. Yeah. So this is the input format, and time complexity and constraints are most important for this problem statement. See, I can do this problem with you see, linear search and binary search. I mean, linear sorting and quick sorting also, but heap sort is more reliable and more trustworthy thing. Yeah. See, uh, yeah. See, you can pause the video and check the time constraints. Yeah, take a pic of it, maybe. Yeah, yeah. This is what the sample input looks like. See, you can see size of the array and okay. See, K is basically yeah, you can understand, right? Okay. See, this is the solution. Yeah, I'm giving you a few moments. If you're gonna try it and code it yourself, please check it out. All right. So see, in heap queue function, as I said earlier, you have to import the heap queue module for that. See, as soon as I import heapq, the whole class heapq class will be imported to me. See, Python doesn't offer any data type like heap. You need to create it by own using let us say, yeah, classes. Okay, yeah. From I think, yeah, here def cookies. You have to start your logic. See, let us say operations is equal to 0. Yeah, okay, heap q dot heapify a, while a k if len of 2 return, okay, new cookie heap q heap pop a plus 2 into heap q dot heap pop a heap heap q dot heap push a comma new cookie. Operations plus is equal to 1, return operations. See, time complexity is given here. See, it takes big of n times, right? See, here see how many loops are running over. There is a, see, heapify gives me one, I mean log n times, okay, log n times, and this heap pop and heap push gives me this heap pop and heap push also gives me log n times, okay. And at the end of the day, what I'll do is big of n. See, big of n minus 1 into log n will be my answer, right? See, n log n will be the time complexity that is used for uh, you know that is used for my heap, I mean heapifying the whole data, and log n will be the time complexity for pushing an element, okay. Now n log n will be my total time complexity. So thank you for having me, I mean, to have your great time. Until then, I'll see you in next video. Bye.